good morning time, good evening time, good afternoon time, whatever the case may be in your part of the world. Crisscrossing wires, and today I'm going to be doing something a little different, or discussing something a little different. You know, for the most part I'm always talking about power, but today I want to focus on connectors and power wire. Alright, it seems as though a lot of people don't fully understand and get that part of this thing. You know, as far as having the right gauge of wire and the right type of connectors, which is very important. It doesn't make sense for you to go and buy a $2,500 battery capable of 300 amps if you cannot get that 300 amps to your controller because of bottlenecks. Bottlenecks in this case being power wire and connectors. Okay, so here you spent all that money on this high performance battery, yet you're not even getting the maximum power from that battery because of your power wires and the connectors you're using. So let's go over that. And I'm going to step outside because it's a nice day. I've been trying to get my outdoor shop straightened up, and yeah, let's discuss all that out here. Okay, and as you can see, it's still a mess in there. We gonna get it back like it used to be. As you can see, I got some stuff set up on this table here, and first thing we're going to do is go over wire gauges. I'm not going to go over all the gauges of wire. I just want you to understand what that number means when it comes to wire. 2 gauge, 4 gauge, 8 gauge, 12 gauge. Okay, when it comes to wire, the higher the number, the smaller the wire. The lower the number, the larger the wire. And I'm talking about its diameter, its thickness, how thick this is. This is 0 gauge wire. Pretty much the biggest single wire you can get. They make bigger wire now, but we don't need to discuss that. These are e-bikes, and normally this is more than what you will ever need. But this is 0 gauge. This is 4 gauge. I don't have anything 8 gauge out on this table, except maybe these power wires here, these phase wires, and yeah, they're probably 8 gauge, maybe a little thicker, not sure. But anyway, let's discuss how you can double your gauge in wires by simply doing just that, doubling up on the wires. Now, is that the optimum way to do it? No. Most of the time, if it's best to use one single wire. However, sometimes you can't always use one single wire because of the connectors you're using. Okay, a lot of people use these QS8s. Okay, now these QS8s are rated at, I believe, 160 amps. Okay, that being said, it doesn't make sense for you to use QS8s if you require more than 160 amps, or you're using power wire that's capable of more than 160 amps. Okay, because this will be a bottleneck. I can't put this connector on a 0 gauge wire. I mean, I could, but it wouldn't be feasible, because if you need that much current that you're having to use 0 gauge, then 160 amp connector is not going to do the job for you. All right, so what you would do in this situation is why you may see this often on a lot of batteries. Instead of having one power wire, they have 2. Okay, now let's say you needed this 0 gauge wire, okay? In order to, well, I can't use that example with this because you really need to use 4 gauge on these, the max. So these 4 gauge wires would be sufficient for these QS8s. But let's say you needed 2 gauge. If you needed 2 gauge and 300 amps, you would be better off using 2 sets of power leads, okay? By using 2 sets of power leads, you would be using 2 connectors, okay? 2 connectors, so you're not trying to run 300 amps through 160 amp connector. You feel me? Now, it's different ways you could wire this connector to your controller, and that would be custom to your needs. You could either put 2 positive wires on this connector and 2 negative wires on the other connector, or you could do them normal, you know, positive, negative on one, positive, negative on the other. However you do it, you need 2 of them, okay? Using 2 of them would take that stress off of one connector. You can burn these out. You know why? Because I've burned them out. Here's one right here. It's not fully burned out, but it was on its way out. I don't know if you could see the inside of there, but the inside of this connector is charred, and you know, you could see where it was burning here. Now what happens is these connectors normally have a very low resistance for optimum current flow, but once you start heating them up and they get corroded and burned and all that, the resistance on these connectors increases, and that means loss in performance, okay? So that can also happen if these connectors aren't connected properly, and by properly I mean pushed all the way in. If you look inside of these connectors, this is the male side, this is the female side for obvious reasons. The only point of contact on these connectors is the side walls in there, and when it pushes in, you know, that's how it's making connections, the side of the connector and the male part. Now if that's not pushed all the way in, you don't have that entire surface area, you know, is not making physical connection. That means if this terminal can handle 160 amps, if you only have it pushed in halfway, you only have 80 amps worth of surface area. So at that point you will start overheating these connectors. So they must be pushed all the way in to get, you know, full connection out of these. You know, I've done that myself. And speaking of, I was talking to a buddy earlier on the phone. They hard to pull apart like this, but it happened to him. He didn't have his pushed all the way in, and started burning his connector. And, you know, I've done that too. I've done it from actually pulling too much power though, but I've also done it from not having them fully connected. But I wanted to explain that because people ask why they see 2 power wires on batteries. That's why. Because you know, like I said, finding a large 0 gauge connector they're not impossible, but you know, they're harder to source than these. So you know, that would make it a lot easier to double up on a smaller gauge power wire, and that always cuts in half. 2 8 gauge wires, if you run 2 8 gauge wires side by side in parallel, that will give you a 4 gauge wire. If you run 2 4 gauge wires in parallel, that will give you a 2 gauge wire. Okay, so it gets smaller and it cuts in half by doubling up. Okay, hopefully everybody got that. I don't explain it correctly all of the time. I try to explain it in a way that everybody gets it, but you know, sometimes I may not have achieved that, but hopefully I got that point across. All right, so make sure you have the proper gauge wire and the proper gauge connector. Otherwise, you're defeating the purpose of having a large power supply, that being your battery. If you can't deliver that 300 amps from that battery to your controller, you know, you're not getting what you should get. You know, that's a bottleneck. Now, also, let me let people understand this. This is a fuse, okay? This is supposed to be a 100 amp fuse. If you look at the element in the middle there, that looks kind of thin. But that's why this is a fuse, because if more than 100 amps is passed through this, that element, it's supposed to burn up in half, and at that point you won't have any more power transfer. Okay, now understand, you can run large amounts of current through small elements if they're only a short distance. You know, it's very low resistance being it a short distance like that. If you were to stretch this element out 8 foot long and then try to run 100 amps through that, it would burn up immediately, because the longer that element is, or the longer the wire is, the more resistance it is. Just like if you had a little skinny 10 gauge wire and you tried to run 200 amps through a 10 gauge wire that was 20 foot long, you would immediately notice that wire would be getting hot. It would at some point start glowing red, then it would burn up. You can't run large amounts of power for long lengths, okay? So that's another reason why, like on my bikes, I've upgraded the phase wires. Like for instance, the phase wires on this motor, are pretty good, and for the length they're probably sufficient. However, you can find another motor where somebody would be running the same amount of power and they would have 10 gauge wires on this. There's no way you could deliver the amount of current that this motor needs through some skinny wires. So you would want to upgrade the phase wires to a larger gauge wire. Now, everyone is not technically savvy to replace the phase wires inside of the actual motor, meaning to be able to take that motor apart and connect and mend the new gauge of wire to the core where this phase wire is connected. And if you don't have that level of technical ability, you could still run a thicker gauge phase wire from your controller and get it as close to your motor as possible. Now, that's not going to be 100% efficient by not running it all the way inside of your motor, but just like what I just described to you in this fuse, high amounts of current being able to travel in shorter distances, it would kind of be the same thing. Although you would not be running a new gauge wire all the way to the inside of your motor, because you would have a thick gauge of wire running as close to your motor as possible, then that current that you need only has to travel a little short distance. And because it's traveling in that short distance, makes it a lot better than if it had to travel the full length of that power wire. So you would still be gaining a lot by extending this phase wire with a thicker wire, at least up to as close to the motor as you can get it. All right, now you would definitely want to run it all the way inside, but you know, everybody can't do that. And not only that, the trouble a lot of times, especially with direct drives, is that the thicker gauge wire can't fit inside the axle. The wire has to actually fit in the axle or run close to the axle when it gets up to the hub and go inside. And a lot of times, you know, it's hard to root it because it's so thick. So, you know, a lot of people can't get that. You would have to drill the holes bigger in the motor casing and everything. But anyway, I just wanted to give that little short, quick lesson in power. You know, there are more than one ways to skin a cat. You know, like I said, if you require more than 160 amps, use 2 of these, 2 sets of power wires. If you need more than that, you can run 3 sets of power wires. You know, you get, hey, you got to do what you got to do. But you know, the best thing would be able to do it with 1. Now, like this 0 gauge wire, if you notice, I have these connectors on here, and they're not optimum to be on this wire because this is by no means a 400 or 500 amp connector. However, if you look, I completely soldered the entire inside of this connector. You know, it's solid. The wire goes in there, and I mean, I put so much solder in there that this whole piece right here is solid. So when it makes connection to my controller, the only distance that current has to travel is you know, like 2 or 3 millimeters. And this is still pretty thick. It's like 0.3 millimeter or 0.4 millimeter thick. It's really thick. I can't even bend this. So you know, that works for that. But most of the time, these connectors are not right at what it's being connected to. These connectors go straight to the controller. I mean, they're right there at the controller. They don't have to travel any more ways through a piece of wire. Most of the time, these connectors are in the middle of 2 wires that are long. You know, if you got this on your battery, you know, that's on your battery side, this is on the controller side, and you still have cable running from this side to your controller. Let me show you. Yeah, like on my controller, see what I'm saying? That power, that 0 gauge is running straight up to the controller. That connector connects directly to the controller, so that's fine. But if, you know, I had to run it longer, like in this situation, now here's what I'm talking about, doubling up on power wires. Now in this Zion bike, it's a Saviton 72150. A 72150 at 150 DC line amps. These 2 8 gauge wires in parallel makes it a 4 gauge wire, which is more than sufficient thickness to handle that amount of current. All right, so that's why it's double, two positive wires and 2 negative wires doubled up. You know, one of these would work on that Saviton, but it wouldn't be optimum, and depending on how long this cable is, it would probably heat up. So 2 of them is sufficient. But yeah, by the way, that's a battery that I'm making for a customer. One of my, you know, one of the 3 that I had to make. I'm on number 2. That's number 2. And people keep asking me about this Garmata seat. Yes, this seat is beautiful because they had no idea that it had this compartment on the inside where I can put my controller. That's the beauty of this seat. Prior to that, my controller had to be on the inside in the battery compartment, and it had to share space with you know, with my battery. So yeah, that seat is fire. But Garmata is in Ukraine, and right now they are helping with the war effort, so they're using e-bikes in the war, so kind of hard to get a Garmata seat right now. Anyway, don't blame me, blame that on what's his name over there, god damn it, Anyway, you know what I'm talking about. Brain freeze. Alright, y'all, take it easy, take care. Crisscrossing wires, just want to go over that with power. Oh, and another thing real quick. Same thing with everything. Doubling up on stuff increases the amount of current flow. Now, let's just say you were going to use a fuse. This one right here is 200 amp. If you needed more than 200 amp fuses in line, what would you do? Same thing like with the power wires. You would use 2 of these blade fuses in parallel. You can fit 2 fuses on there, 2 of them side by side in parallel. Instead of 200 amps, it would be 400 amps. All right, so that's how you do that if you wanted to use an inline fuse. That is most we can say. This right here is a pack that I made. When I first made my battery pack, I wanted to have the option to run 72 volts or 96 volts. So if I wanted to run 96 volts, I could run this pack in line with my 72 volt pack and have 96 volts. All right, and notice I had because I have 2 packs making my entire pack, I had 2 gauges, 2 4 gauges on each side to connect to both of those packs, and had a 0 gauge coming out onto the controller. Gotta make sure you have enough gauge of wire to handle the amount of current that you're trying to run. And I was trying to run a lot of current, so I needed that. Right now I'm just running 21S system, so I no longer need this anymore. I'm running 21S, which is 75 volts nominal, 88 fully charged. Okie doke, that's it. Take care. Crisscrossing wires. Deuces, we out. Peace.